Molarity is a way to express the concentration of your solution. We're much more used to using percent for determining the concentration of a solution. So we learned about weight over volume percent, which is the weight of our solute divided by the volume of our solution times 100 to make it a percent. We also learned about volume over volume percent, which is the volume of our solute divided by the volume of our solution times 100. But molarity is what's commonly used in a chemistry lab. So if we look at our solutions down here in the bottom in this picture, they have a number and then a big M written next to them and then the name of the compound. So in the laboratory, we've been using different compounds and they're all expressed with this big M. Big M stands for molarity and is abbreviated with a big M. What molarity is, it's the moles of your solute divided by the liter of your solution. So the formula for that is written down here below. So let me just write that in a format that's a little easier to see. It's moles per liter. Okay, so that's a formula that you want to remember is for molarity. So if we were to make a solution and we wanted to make a 1 molar solution and we were going to use salt, salt would be our solute, what's being dissolved by our solvent, which would be water. And if we wanted a 1 molar solution, it would contain 1 mole of sodium chloride dissolved in water to get a total volume of 1 liter of solution. So this is showing you how you could make it. Now when we go into the laboratory, we don't actually have scales that measure in moles. They need to be, our scales all measured in grams. So in this slide, we're showing that you can actually weigh out 58.44 grams of salt and put that into this volumetric flask. So in order to convert 1 mole to grams, we'd have to use a molar mass that we've learned before. So moles to grams. Use your periodic table to determine the molar mass of salt and of chlorine and add them together. So that's how we got 58.44 grams of salt. So you went ahead and poured the compound into your volumetric flask. How the volumetric flask works is it measures, in this case, exactly 1 liter. Okay, so there's a mark that's etched on the volumetric flask. When you pour your solution in and you have a total solution where the bottom of the meniscus just touches the top of that line, that would be exactly your 1.0 liters of solution. So if you were actually making the solution in the laboratory, you'd pour in your compound. Usually what I would do is fill it about halfway with deionized water, swirl that around to mix it, because that will help dissolve it. It's a little harder once you put the water all the way up in the skinny portion or the neck of your volumetric flask. But then you would go ahead, fill up your water all the way to the mark, so we know our total volume of solution is 1 liter, and then you can mix it thoroughly by capping the solution. And then you have your 1 molar solution of sodium chloride. In this example, you're asked to calculate the molarity of a solution that's made by dissolving 2.58 grams of sodium chloride, which will be your solute, in enough water to make a solution with a total volume of 0.100 liters. Now our formula for molarity, capital big M stands for molarity, is moles of solute divided by the liters of your solution. Okay? In this problem, we're not given the moles of sodium chloride, we're given the grams. And so we can convert grams, 2.58 grams of sodium chloride to moles using our molar mass of NaCl. So just as a little review, you would say sodium, using your periodic table, weighs 22.990 grams per mole. Chlorine is equal to 35.45 grams per mole. When we add those together, we get 58.44 grams per mole for sodium chloride. Then we can go ahead and solve for our moles of sodium chloride by taking our 2.58 grams and using the molar mass. We want to set that up, so we'll cancel our units. So we're going to put 58.44 grams of salt at the bottom, and this is for 1 mole of salt, how much it weighs. And then when we divide, we end up getting 0.0440 moles of sodium chloride, which is our solute. Now we can go back to solving for molarity. Big M is equal to 0.0440 moles of sodium chloride in what's given in the problem is we have 0.100 liters of solution. So it's sodium chloride, the solute, divided by the solution, and that's going to give us an answer of 0.440 moles per liter. Here's another molarity example. In this example, we want to know the molarity when we have 47.0 grams of KCl, which is our solute, when it's dissolved in enough water to give us a total volume of solution of 375 milliliters. So again, molarity is equal to moles per liter. And in this case, our moles of solute is 47 grams, so we have to convert that from grams to moles. So in this problem, I gave you the molar mass just to save a little bit time. Instead of using our periodic table, it's just recorded here for you. So in canceling our units, we have 74.548 grams of sodium chloride is what 1 mole, KCl potassium chloride weighs. Okay, so then our grams of KCl cancel. We end up getting moles of potassium chloride, and those moles equal 0.630 moles of potassium chloride, our solute. And then again, our formula is moles of KCl per liter of solution. In this case, our solution, the units are not in liters, so we need to convert that. We have let me erase that. We have 375 milliliters, and we want to convert that to liters. So we know there's 1,000 milliliters in 1 liter. So 375 divided by 1,000 gives us 0.375 liters of our solution. So now we can go back to our formula for molarity, and we have 0.630 moles of KCl divided by 0.375 liters of solution. So it's always important that you have the correct units. Molarity always has to be moles per liter. So if you have a different unit for your quantity of your solvent or your solute or your solution, then they need to be changed. So we have 0.630 divided by 0.375. That equals 1.68 moles per liter. And you could also just abbreviate it with a big M if you wanted to for your final answer. Okay, so we did a couple problems where you calculated the molarity of your solution. You may be given a problem where you're given the molarity of a solution and possibly given maybe the volume of your solution and then asked to find maybe the moles of the solution. Or you might be given the moles and asked to find the volume of your solution, and you're also given the molarity. So molarity is in a fraction format already. Remember, big M is moles over liter. Don't forget that. So it's in a fraction format already, so we can use that as a conversion factor as we have previously learned. So we did an example earlier with sodium chloride, and in that example we calculated sodium chloride solution to be 0.440 moles of salt per liter of solution. Now we can flip our fraction upside down because those are equivalent to each other. So we have 0.440 moles of NaCl, could also be written on the bottom. So we can use this to go ahead and do a problem. So let's say we were given a problem and you were given 0.10 liters of solution. And then my question for you might be, how many moles is that equal to? And we're given the molarity of 0.440 m. So we would set up our problem as always with what we're given, 0.100 liters of solution. Now is where we're going to use our molarity as our conversion factor. So we can pick, we have the one on the left with 1 liter of solution at the bottom, or the one on the right with has 1 liter of solution at the top. We want to be able to cancel our units for liters. So we pick the one on the left as our conversion factor. So 1 liter of solution will go at the bottom. 0.440 moles of sodium chloride would be at the top. Then our liters will cancel. 0.1 times 0.440 gives me 0.0440 moles of sodium chloride, which is what you found in the other problem. That's what you were given, but this is just showing you we could actually calculate using molarity to determine either moles or liters of your solution. Using molarity to convert from moles to liters or liters to moles is just like we learned previously when we learned how to convert grams to moles, moles to grams, use molar mass, clap, clap, clap. Okay, it would be the same idea. We can go liters to moles, moles to liters, use molarity, clap, clap, clap. Just to help you remember that. Just another way to help you remember. We did grams to moles to grams, use molar mass. Liters to moles to liters, use molarity, clap, clap, clap. So what I have up here is an analogy to kind of help us remember. We've talked about some conversions in the past. And so in this analogy, we have some mole people that live in Mole Town. That's the center of the universe here. And the people in Mole Town, when they want to go visit their friends in Gramville, there's a 2-lane road they can take. And the 2-lane road, to go from moles to grams, they have to use this 2-lane road called molar mass. Okay, so to convert from moles to grams or grams to moles, depending on which way you're going, is you use molar mass, which is grams per mole or moles per gram, to do that. We also learned how to convert from moles to molecules or atoms. And in Mole Town, when the people die, they go up to molecule heaven. And in molecule heaven, they also believe in Mole Town that you can be reincarnated. So it is possible to come back to Earth in your next life. So in order to go from moles to molecules, or we can also call this atoms if we wanted, you use Avogadro's number. So depending on how we set up the problem, it's either Avogadro's number divided by moles or moles divided by Avogadro's number, which again was 6.02 times 10 to the 23rd. So this is sort of an overview of tying together what we've learned. Our new part today is the Mole Town people, they like to go out and have fun, so they go to Leaderland for their fun. In order to go to Leaderland, again, a 2-lane road, one way to get there and the same road to get back, depending on how you set up your problem, is using molarity. So it's the molarity highway to get there. And again, we can set up our problem with liters at the top or liters at the bottom, depending on the conversion you're doing. Showing this an example here is the same idea of doing our conversions. Here we have a volume of our solution that would be in liters. Going to moles, we can use concentration in molarity. And again, this is a big M for molarity. We can go from moles of one substance. We can also go to moles of a different substance. So this is tying together some more ideas that we've learned. Moles of A to moles of B, a different substance. Let me write that in the right spot. We use what we call the mole ratio, also known as the coefficients in your balanced equation. And if we have moles of one substance, we can go to grams of that substance using molar mass to get to grams of B. So this was just showing you some examples down here of maybe if we had 400 liters of a solution of gold cyanide and we had the molarity of it. We could calculate the moles of that. And then if we wanted to go from moles of our solution to moles of just the gold, AU is gold, we could use the balanced equation to calculate that. And then from moles of gold, we can go to grams of gold using the molar mass. This example gives us the concentration of sodium chloride in blood serum is 0.14 molarity. Molarity again is moles per liter of solute over liters of solution. So we want to figure out what is our solute and what is our solution. So sodium chloride is what is being dissolved. So that is my solute. And blood serum is my solution. That's the salt plus whatever else is dissolved in the blood to make my solution. The question is asking for what volume of blood serum, so that's my solution. That's what I'm looking for in this problem, is the liters of the solution. It says milliliters, but we'll calculate liters and then convert that to milliliters. It says the blood serum contains 2 grams of sodium chloride, which is our solute. So in order to solve this problem, the solute is given in grams, so we must convert that into moles. So we'll start with 2 grams of sodium chloride. We'll use the molar mass to convert that into moles. So 1 mole of sodium chloride weighs 58.5 grams. And I'm putting this on the bottom so my gram units will cancel. So 2 divided by 58.5 gives me 0.034188 moles of sodium chloride. Okay, so now I have my moles of solute that I need. I'm looking for the liters of the solution, that's my question, and I'm given molarity. So we just learned that we can go from moles to liters or liters to moles using molarity. So let's go ahead and set this up by saying we are given 0.034188 moles of sodium chloride. We are trying to find the volume of our solution. So I'm going to say liters of solution. We eventually want to get to milliliters of solution. And to go from moles to liters, we use the molarity of our solution. So we can solve our problem once we have our plan written out. So we have 0.031488 moles of sodium chloride. We can use our molarity. Molarity again is moles per liter. So in this example, we want our moles at the bottom to cancel units. So molarity is 0.14 moles of sodium chloride per 1 liter of solution. And so this way our moles of sodium chloride cancel, we get liters of solution. So for liters of solution, it comes out to 0.24 liters. And then to get it into milliliters, we just need to say 1 liter is equal to 1,000 milliliters. And we end up getting 2,400, and I have 42 milliliters. There must have been a 2 here. And then for sig figs in this problem, we have 2 sig figs because molarity has 2 grams has 2. So in order to put that with 2 sig figs, we have to put in an exponential notation. So it's 2.4 times 10 cubed milliliters. That's my final answer. Okay, this is a summary of the concentration units that I want you to know. The first one is weight by volume percent, which is the weight of your solute divided by the volume of your solution. The units for this one are grams of solute divided by milliliters of solution. And then to make it the percent, you would times it by 100. So you need to know the formulas for this and you need to know the weight. Percent by volume is just the volume of your solute divided by the total volume of the solution. What matters for this one is your units match. So you may have milliliters over milliliters, and again, you times by 100 to get a percent. It could be liters over liter times 100. It's just so long as the units for the solute and the solution match each other. Molarity, the third one to remember for this chapter, is moles of solute divided by 1 liter of solution.